Good morning, good afternoon, good evening, folks joining from different locations, different industries. I really appreciate for you to taking the time to dive into this session. So let's get started in the interest of time here. So we'll first take a look at Emerson, which is where I'm representing currently. So Emerson's transformation, which an energized focus, falls into basically two business platforms: the automation solutions, commercial and residential solutions. So these platforms confront the challenges of an increasingly complex and unpredictable marketplace from a position of strength, driving near and long-term value as a trusted partner for our customers. And more importantly, automation solution making the greatest use of the world's valuable resources, helping nations move their economies forward in a responsible way, enabling the performance and safety of industry when it matters the most, advancing the industries that are the backbone of our daily life. And commercial and residential platform that we serve helps to ensure human comfort and health, protecting food quality and sustainability, advancing energy efficiency and environmental conservation, creating sustainable infrastructure, fully dedicating to improve the quality of lives around the globe. The company was founded in 1890, headquartered in St. Louis, United States. We are ranked number 176 in Fortune 500 America's largest corporations by revenue in 2021, listed in the Women's Engineering magazine as top 50 employers, and also in the Forbes magazine under the category of world's best employers, world's most admired companies. The company has a workforce of nearly 83,500 employees spread across the globe in 200 manufacturing locations. And in innovation, we take pride in holding nearly 20K active patents. I could take the number as of 2019, and you could see the logo of Emerson that I have shown right above the text Emerson, helical spiral, in blue and gray, basically representing, we combine engineering and technology. We are passionate about combining our engineering and technology to help customers in the world's most essential industries, solving the biggest challenges of modern life. The company made global sales of about 16.8 billion in 2020, giving our shareholders 65 years of increased dividends, and in the New York Stock Exchange ticker symbol with the EMR. Looking at the industries we serve multitude of industries, as you can see, and on the right I have listed products from flow controls, representing the Emerson automation solutions, primarily the Fisher brand here, which is what I have listed. In 3 rows of our standard globe valves on the left, and our engineered severe service solutions on the right, our rotary ball valves and butterfly valves, and our the DVC controllers. Now moving on to the project or the topic of discussion, responding to dynamic market requirements. So what we have come up with is by collaborating with the technology partner like Configit, is we built the next gen control valve code tool. Now control valve dates back to several years ago. I mean, we are a company, the Fisher exists for over 140-50 years. So as such, the control valve technology is not something new, and we take pride in saying that we are the pioneers of doing control valve engineering. The founder of our brand, Fisher, he was the one who invented the product. So why next gen? I'm going to cover that in probably 2 slides. I'll just start off with this one. So why did we build a next gen control valve code tool? Well, we wanted to build a tool that that's intelligent, intuitive, faster, and simpler to engineer control valves. And how did we do that? Is by combining the modern technology with our deep engineering knowledge in building Fisher sizing and selection programs over the years. I mean, since the invention of computers, and even before that, the technology of control valve existed in the market. And we have built several tools over the decades, in building applications for different requirements. So that deep engineering knowledge, and by combining the modern technology, we build the next gen core tool, as we always try to stay ahead in the market by offering our customers high quality products and services through innovation and technology. We also wanted to align with the overall Emerson digitization strategy of building a tools digital ecosystem, where this next gen control valve code tool will take a primary spot in that ecosystem. And also from an information technology and agile development standpoint, we also moved into secured cloud platforms, in streamlining the IT vision and providing a single global instance tool for Emerson and its sales partners. So those are the whys of why we built the next gen control valve code tool. Now on the right, I'm showing a bit of an evolution, giving you an analogy on the right bottom, how the mobile technology, evolved over time. Self-explanatory, since 1980, day by day, you see new models are coming. The technology is catching up so fast there. Now, looking at control valve, from a tool standpoint, the product sizing and selection of control valves, goes back several years ago, with traditional sizing methods, manual methods using reference nomographs and your sizing slide rules, into the era when associations like ISA, IEC, and FCI have established standard equations for sizing and selection. We were also the early adapters of such standardization and importing those computations into our sizing program back then. And that was, I'm talking about early 1970s. And then in 1990s, we are also one of the early adapters of including CPQ, which is configure price code, into the sizing control valve engineering. So the CPQ, offers a lot of intelligence from a selection standpoint, not primarily on the sizing standpoint. That still exists, some sort of a bridge between your sizing output that feeds into the input of your CPQ for selection purposes. So it's an automation, but it's not a fully automated intelligence solution, that we were, using since 1990s. And here in 2020, we developed this next gen code tool. I'd say the intelligent automation of control valve engineering. So I'll get into the details of what this intelligent automation means. That talks about this next gen control valve. So this evolution, is something that we are very proud of, because in all the steps that you see here, that Fisher Emerson were one of the early adapters of this. Now, moving on to the next one, the next biggest thing that is driving a change in the quotation tools, the sizing and selection of the control valve engineering tool, is the market dynamics that are going around. So I would probably relate it to something that was happening prior to COVID time, because COVID has literally changed the world, different sectors, very differently. We are sensing the changes that are happening post COVID here, but I mean, we are still getting out of it, completely. But looking at the market dynamics, under three sections, I can say one is the concurrent engineering that happens at our industry to the customers that we serve for, where they run into shorter schedules, these process plants that are involving several equipments, and there are equipments that have a very longer lead time, and especially the ACE professionals, who are our architecture, engineering, and construction professionals. They need an insight into the infrastructure of the plant that is being built to efficiently plan and design, construct, and manage it. So all these are driving a lot of concurrent engineering taking place at our industry that compels us to be more responsive to their requirements. That's one key thing. And moving on to the next one, which is more data at the feed, which is the front-end engineering design. So we used to do feed projects with very minimal data, where you are not equipped with a lot of data to even do sizing. You basically do a line code, but we are seeing more and more feed with complete information. So when there is more information coming from customer, you have to do a better engineering. You have to do a better job, for them to help understand the cost and schedule estimates. And also these feed work, the kind of engineering data that we send back to customer based on the process inputs they supply also helps them to double check with other adjacent instrumentation products, be it piping or heat exchangers or compressors. It helps them to also cross check the data and making sure that everything is in line, and when the fluid flows through, it does the job of what it is intended for, and looking for detailed budgetary codes. The third one is mega projects, one project managed by multiple EPCs, multiple sites managing engineering and procurement. So all of these adds a lot of expectation on the vendors, especially the control valve vendors, to have efficient tools that has the speed, that has the flexibility, and also the accuracy in terms of the product configuration that they quote back to the customers. So I have just illustrated pictorially the operations within the selection process. Starts off with the sizing and selection, then you do a configuration and getting a price, and then you're quoting it to the customer. And all of the factors I talked about on the left is making you to make to do revisions, accommodating the changes that the customers are imposing on us from a process data edits, from a product design changes, or the certification and compliance changes. All of these are putting us an expectation for us to build a tool that is speed, flexible, and accurate. So that's the industry expectations. On the other hand, like I said, we were early adapters or innovators of things that happened over time in the control and engineering process. So Fisher as a brand, we are number one in the market. So number one gives you pride, but it also gives you an equal a responsibility to evolve things, to stay ahead in the market and be ready to solve our customer needs. Now, I'm moving on to the CPQ aspect of it. So we saw, what was compelling us to build robust, sizing tool. Okay, so now what are the challenges within the the CPQ platform? So we'll look at first the CPQ product model aspects of it. So the product model, I would say, can be defined as the basic physical building blocks of the product, in terms of what they do, what their interfaces are to the rest of the device. And it also plays a significant role in how to design, make, sell, and repair, when it comes to MRO and life cycle services of any product offering. Since its launch as a brand new product, when it was sustained and maintained, making changes to the product features, to meet the customer needs, or when it was finally made obsolete with the successor. So the product model, as I said, is the building block that holds the rules, that holds the feature information of a project. Now, of a product, sorry. So if you take any product, it has multiple features associated to it, and the features are not independent. They're all interlinked. What I mean is, on the right, if you see a matrix that was developed with a product, let's say, that has 10 features, okay, in it, so or attributes in it, and I have marked here and there like a chessboard, right? But I have marked here and there some orange coding, and what it means is, if you look at F1 column, it has an intersection on F3 row and F9 row. So the feature one of the product has a dependency on feature 3 and feature 9. Okay, so any configuration I do, I assign a value to that feature 1, has a direct impact on what the values of feature 3 and feature 9 can be, which is fine. It helps you to configure, right? Because when you have more dependency with less, by setting less values on the feature, that your rest of the features get auto-defined, which is good. But what happens when you make changes? We talked about all the dynamics that are happening, where you have to revise things when the customer requirements changes, right? So when you make changes to it, your configurator should not be making you to, okay, now unwind everything, unlock everything and start from scratch. It shouldn't be like that. It should let you to make the changes. It should let you to inform you the changes. If you change F1, by the way, these are the things that are affected, and this is how it is affected. Okay, and allow you to respond to that conflict, as opposed to blocking it. Okay, so in essence, if I have to list out about product model attributes here. So the product model basically governs the form, fit, function of your control valve assembly, and a clear and concise product attribute dependency matrix. An illustration I've given just above that, this matrix yields configuration accurately, and it allows flexibility also. Why I say that is because any customer process or specification changes have a direct impact on your on your configuration. So the configurability of your CPQ is very important in deciding how quickly it lets you to make the changes, not only with speed but also with accuracy. And product model from a control valve standpoint, it encodes the physical design features of it, the thermal and pressure limits of it. So it encompasses several characteristics. It could be dimensional, functional, chemical, material, or thermal property of a product. So before we moving on into, okay, what how Configit was enabling us to build the next gen the core tool, it is important to understand a rich and robust product model is a prerequisite to make and revise codes faster with high level of accuracy. And then I'll just go through the control valve engineering process in a very basic manner. So we are talking about here control valves, and that are served in the industries that I just showed you in my third slide. And the process of selecting a control valve starts from the very basic of the application service that it is serving. Okay, the control valve that I'm going to install, it could feed a boiler, it could safeguard a compressor as an anti-surge valve, it could regulate a pressure or control a flow, or regulate your temperature. So there are just n number of applications based on the industry the control valve is installed. So it all starts with the application and the process fluids that are involved, that the control valve is actually handling, and then it moves on into the next step of trying to understand the aerodynamic and hydrodynamic behavior of the product of the fluid as it flows through the control valve. So by knowing the behavior of it, you then decide the internal components of the control valve that you have to choose, so as to address the hydrodynamic or the aerodynamic behavior of the fluid that you're passing. And then you go about fulfilling the other attributes of your control valve, and finally finishing off the entire assembly. So it's an engineering. I just did a very quick walkthrough of the steps involved here. So the best suited products here are a result of your ISA, IEC, the governance, the computations, the algorithm that are involved, the behavior of the fluid from a hydrodynamic and aerodynamic standpoint, the requirements from the customer from a material, operating and design limits, the fugitive emissions, noise levels, certifications. So all of these play a key factor in what your configuration is going to be. Okay, and of course the commercial aspects and the lead time of the product expected. So on the right, I'm showing a traditional method where the selection starts from entering the process conditions up to sizing it, configuring it, and then finishing off a linear process here. So mentioned in the green box, customer change request can associate product reevaluation at any or all of the process flow blocks in the linear valve engineering model illustrated above. So if a change from the customer is changing a valve feature, you have to make the change, and then you go all the way to redoing your actuator if the change on the valve has an impact on it, or if the change is actually on the process condition, you actually start from there and then do it. So that is a CPQ enable. Like I said, we kind of invented back in 1990 and have been using it. The CPQ enabled process. Now what we move into is an SSCPQ, which is size, select, configure, price, quote process, where what we do here is, by combining technology and engineering, is we empower sales to evaluate more products faster than ever before. Whereas the chart above talks about a linear model, a human evaluating options, whereas a technology enabled solution empowers sales to evaluate more options faster than before. So how did we build this SSCPQ platform? There are several focus areas here for us while building it, but I'm only focusing on 3 things, reading from bottom to top. Leverage existing product model data as it is, SSCPQ technologies, and completely a custom made product. So there are a few key enablers that we were very much interested in. Focusing on the strength of CPQ on one side, on the other side looking at the features of the application, from a workspace management standpoint, being collaborative, tag management, batch processing, conflict resolution, and imparting intelligent automation in the control valve engineering. So those are the enablers for us to look at it. Now on the right, let me just focus only on the middle layer, which is the vendor evaluation process. So we are a subscriber of Gartner's research. So we look at the research done by them on the CPQ domain. We looked at different players there and the capabilities there. We had a dedicated team that was looking at the different solutions. We had about 10 suppliers, including including evolving our current CPQ as an option. So that's also one of the options, along with other CPQ suppliers. We did proof of concept with 3 best suppliers based on an evaluation that we followed, and finally picked Configit to be the one to go with. Now, why Configit? So these are materials that those who are following on the CPQ technology should be aware of from a Configit standpoint, but I'll just quickly go over which are very key also in this presentation. So now looking at CPK evolution over time. Okay, so you see in 70s and 90s had a production rule-based systems, just tabular form, rules over rules over rules, inclusion, mostly inclusion, because we didn't have quite an intelligent platform that supports exclusion. Okay, inclusion means you have to write a lot, and then moved on to a constraint-based system. So constraint-based system has its own merits and demerits. It reacts on the fly. It just reacts on demand. Whereas the compilation-based virtual tabulation, which is what Configit had patented, is a configurator that pre-compiles the solution space. So the solution space is already ready. It's ready to get fired. So meaning based on the user request, the compiler is able to react very quickly, as opposed to solving the problem runtime. When you solve the problem during the runtime, you are slower as compared to a pre-compiled solution. So benefits of VT, just from my explanation: full guidance, performance, correctness, bomb validation, optimization. So these are the key benefits of the virtual tabulation, I would say. And on the right top, specifically on looking at our project, we were able to do a seamless data import using our current product model, which I would say is nearly 50 man years old. I mean, we have had product model built for several decades, but if you look at the transformation of the data in the last 20-25 years to support our current CPQ, I'm not talking about the next gen CPQ, the current CPQ is about 50 man years, having over 1 million rules, covering 500 plus products. I'm not only talking about valves and actuators, I'm talking about accessories and other services as well. So such a rich product model, Configit is able to compile it, in a smaller size, without us having to redo the model. Just use it as it is. So the current system is already using it. The next gen tool is also enabled to use it. So my final solution summary here, probably going a bit faster maybe. So my final solution summary here is so what we have done is, through intelligent automation that combines technology, engineering, the control valve engineering, the rich and robust product model, and the business logic. The orchestration of this is what has produced, Emerson's next gen control valve rotation tool, which is quick and easy for users to size and select, a reliable solution leveraging the existing code tool rules to apply technical limits, because we have been using our current CPQ for over 20 years, which we trust the way the rules are written, the way the validation is done, and when the same rules can go into Configit, there's absolutely reliability there. We can trust on the validations that are happening in the new next gen platform, and it was just quicker for us to develop and roll out. What I mean is, maybe I'll just cover it down below. So the two aspects of the Configit, the VT engine, was adaptable, highly adaptable to take our product model as it is, with high level of data integrity. Like I said, we didn't have to edit or redo the model. Okay, so that was a big thing for us. And then rules can be in any form, even though we have a particular way of writing the rules. we really appreciate the flexibility that is being offered, with if then else inclusion and exclusion. So, you can write it in all these forms, fast and error-free encoding of data, because, when the product modeling was done with an oversight, let's say with some gaps in it, the Configit has the ability to decode and explain why. If the compilation fails, you have the ability to look into where the gaps are, from a modeling standpoint. And obviously, the power of VT, which is a pre-compile versus on the fly or runtime, or solving the problem runtime. That's absolutely a difference in the response speed of such a technology. The API that they offer, the REST APIs, faster, and plug and play with our custom UI application for the custom features that we built in, the key enablers that I talked about. So wherever required, we were able to easily plug and play with the API. So with that said, if I were to list out the advantages of Emerson's next-gen control valve code tool, it empowers our valve engineers, or so-called the product advisors for our customers, with speed, because it lets them to evaluate more options faster. And it brings a standardization in the control valve engineering workflow. It effectively manages the standard portfolio and the specials, which is the engineer to order ETO and the CTO. Very flexible. You can seamlessly, move away from a standards to a special mode with such with the configurator. Provides high code quality, and most importantly, designed for millennials and the next gen set. So with that, I'm closing my speech on the project, and sharing our our experiences with Configit. So I must say that it was really outstanding, and I was happy when I was asked to make this presentation. Was pleased, and I only get to speak here, but there are a lot of people who worked on this this program from Emerson. I'm just a spokesperson on behalf of the team, so we are extremely delighted with this engagement. So thank you.
My question is, who are the end users of this application, and what has been their best feedback so far, or what has been their feedback so far?
Yeah, so the end users of the application is our application engineers, our sales, our inside sales. They are the folks who would use it. But looking at the collaborative nature of the tool that we have built here, we are encouraging our our sales and application engineering community who are focused around mega projects. So those are, I would say, the early adapters of this tool. From a feedback standpoint, yeah, we have done a pilot. We went live late last year, and the adoption is going well. There has been good feedback. Like I said, it the tool kind of complements the empirical human knowledge. We have people with 20 years of experience, and we have people, some recent millennials as well. So the guidance that the tool offers, I don't need to have an experienced guy. The tool is giving me the intelligence. So that is being greatly appreciated by the early adapters so far.
Fantastic. So I have another question here that's also come through. What are the benefits for you using an out-of-the-box software application in comparison to developing an in-house solution? Or do you see hybrid setup as the best approach with the best of both worlds?
Yeah, so I would vote for the hybrid solution here, because when you say out of the box as a tool, okay, so tool is one thing, and the business process that kinds of governs other elements like your UI and features and things like that, right? So should business process or the process drive the tools, or the tools drive the process? Who is superior? I think that there are multiple dimensions to say, who should drive what. But we feel, the hybrid of both is the best solution. As you can see, ours was a custom built application. The UI, the features custom built, the CPQ was customized and patented. So I would prefer a hybrid. Is the best solution for us.
What was the quality of the data like? Was it already in place for you, or did you have to go through the master data before putting it into CPQ?
Yeah, so our data, that is serving our current CPQ platform, which is active, since mid, I'd say 96. Yeah, I mean, just a rich product model, well-maintained product model, and the quality was outstanding, because it's serving our business for over 2 decades. And our main concern was, can we take it as it is to Configit? And the answer is yes. So
did the role of the ERP system change after implementing Configit?
No. The area that we are looking at here is the quotation platform, and that is what we have not changed. We have kind of evolved from what we have today into into this next gen quotation tool. So this has no impediment or no dependency on the ERP. Our ERP exists as it is.
Where is the sizing tool installed? Is that within Configit, or is it with a separate tool that is integrated with Configit?
The solution, like I said, we have combined, here the technology, the sizing part, especially here is, I'm sure it's the engineer, the engineering aspect, the product model, the business logic. So it all resides in one spot, a centralized location, like you said, and it's a global instance. So we are not, we're not having any offline versions or letting versions sit on a user machine that can get outdated. So
how is the ETO or engineer to order process integrated, I'm assuming, into Configit here?
Yeah, so I mean, be it any configuration platform, the configurator works off of what is defined in the product model, and anything outside that spectrum is an unknown to the configurator, and all such unknown is consumed on the user interface as ETO, and we have a specific way of consuming such out of the box product rules or the product model as our ETO configuration. So I think I can only explain up to this level, given the complexity around ETO. So I can still say for sure that Configit does that differentiation or the classification for us to know whether the solution space that the user wants to configure is within the CTO segment or the ETO segment. So we tap that that feature within Configit.
All right. You mentioned that the users are predominantly internal or technical users. And the question is, do you envision bringing the configurators online towards the customer as like a self-service approach? And if so, what would be your considerations for that?
Yeah, so we already have tools that are available for our customers to use. One of the latest version or the name of it is called Fisher Valve Specification Manager, and it is in place for quite some time, and the prior versions of it is existing for a very long time. So that facility is there, but the question of actually exposing this to customer directly, absolutely we will look at it based on whatever our customers or industries or wanting to. So that's probably something for our leaders, for our business leaders to decide.